First and foremost, I want to keep this professional and very cordial. I don't want any personal attacks or anything going on in this. This is a professional and scientific debate, not a wrestling match.
Yeah, you just heard from Gregory Wrightstone here on the left. He's a geologist, former Eastern Section president, author of Inconvenient Facts, and he asked us to say that it's the #1 bestseller in 6 Amazon categories, including science. He's an expert reviewer for UN IPCC reports. David Cole is a professor, Department of Earth Science, Ohio State University. He's a director of subsurface energy materials characterization. And he's in geochemistry and geologic carbon sequestration expert. And James Kasting, he was, for the first speaker, he's from Penn State University, distinguished professor in geoscience, world-renowned expert in planetary habitability, widely published author on paleoclimate modeling. So if you have any modeling questions, he's the guy you want to ask. So, I mean, the first thing we want to do when we start out here is ask the panelists to ask one other panelist a question, if you don't mind. And we'll start with Dr. Kasting.
Okay, well, I'd like to ask Greg a question. Greg, you put up a record of CO2 and temperature over the Phanerozoic, the last roughly 500 or 600 million years, and said there was no correlation. Did you take into account solar luminosity change during that time?
I did not. I reported the data as it was presented, just the historical geologic record of CO2 versus temperature.
So, one of the problems I've worked on for 40 years is called the faint young sun problem. The sun started out 30% dimmer than it is today, and it's been brightening over time as a result of nuclear fusion going on in its core. The current rate of brightening for the last several hundred million years is about 1% every 100 million years. So if you go back 600 million years, the sun was about 6% less bright than it is today. And fortunately, there's a negative feedback cycle in the carbon cycle that we think pumps more CO2 into the atmosphere when the climate gets cold. If you didn't have high CO2 500 or 600 million years ago, the Earth would have been an ice ball.
Well, we'll just respond to that, maybe we'll move on to the next one, but we see that would lead, what you're contending is that would lead then to fairly gradual temperature and CO2 changes, I would imagine. But what we see are pretty significant, both temperature and CO2 changes. That would argue against that. So I'm no expert on solar luminosity, but I did capture the data as presented for temperature and CO2.
David, do you have a question for one of the other panelists?
Well, yeah, I'm at a disadvantage because I'm not familiar with your book, Greg, but when you present your results, you cite some key studies, the Mann book, for example, which I'm not familiar with. So, most of us in the science arena, when we publish a paper, we have hundreds or maybe more than hundreds of references that we're using. So I guess I'm simply asking a question out of naivety in terms of what you cite as evidence. I hope you're taking more into account than just a few point sources of informatics.
I appreciate your comment. It's hard to do too much of a 20-minute presentation. So, and you asked about the book. I've got 14 pages of references, mostly from NASA, NOAA peer-reviewed studies. And again, there was just the Michael Mann issue with the hockey stick. I could have talked for 3 hours about it and go through in detail, but I wanted to pick out some of the main points of why Michael Mann's hockey stick was wrong. And again, I probably did disservice to the people who have really spent the time on it, and I'd encourage you to look into it a little bit more to find out about this.
Finally, Greg, do you have a question?
Well, I'll ask Jim, as you expected. It sounds like you believe that, obviously you believe that the warming that's predicted will lead to catastrophic temperatures. What's the ideal temperature for the Earth?
The Earth doesn't care what its temperature is, all right? Humans evolved during the Ice Age. You know, you showed temperatures going back 140 million years. The peak temperatures were in the early Eocene, about 55 million years ago, a little before that, and in about the mid-Cretaceous, about 100 million years ago. The estimates are that it was, say, 8 or 9 degrees Celsius warmer than today. The wet bulb temperatures maximum wet bulb temperatures go at about 2/3 of the global temperature change. So at that time, 100 million years ago, maximum wet bulb temperatures in the tropics would have been about 6 degrees warmer than today. Humans could not have lived 100 million years ago because we evolved after that time when the Earth was much cooler. And in fact, very few mammals alive today could have lived then. Fortunately, they've had tens of millions of years to evolve, and you evolve, as Nina Jablonski would tell you, you evolve to some point where you're within your heat stress limits.
Thank you. Let me just ask each of you to, and let's keep our answers as brief as possible. You know, the big question I think that all of us have of this whole topic is climate change, global warming, whatever we want to call it, is it really the crisis that some alarmists make it to be, or is it not such a crisis, or is it nothing to worry about at all? Start with you, Greg.
Again, I look back through human history and relate that to the other warming periods. If we see similar warming that we've seen in the past, and I'm often asked what's going to happen with the temperatures, and as a geologist, I like to look back at what's happened in the past and say what's probably going to happen again. If this warming period is like the others, we'll probably have another degree or two or whatever, a degree and a half of warming. Maybe it'll last another 80 years. On the other hand, there are people I respect greatly that are promoting a cooling coming up here. But I'm a big proponent of the relationship between warming, and we've seen it in the past through historical relationships, the relationship between rising temperatures, increasing crop production. We didn't see catastrophic events occur in the last 4,000 or 5,000 years of history, and I don't think we're going to see them now. These are projections made on climate models about what might happen 50 or 80 or 100 years in the future. And what I do is I look at what's actually happening today, and I see an Earth that's thriving, prospering, greening, and humanity's benefiting because of it.
Well, that's an interesting comment. I don't know. I'm not a meteorologist. I'm not an observer, a keen observer of humankind. We are seeing change. We're seeing migration of peoples. We're seeing policy decisions made on political motivations, but also we see weather extremes. And so one could comment that maybe this is the typical natural evolution of where we are in time and space with respect to Earth, as you would point out, Greg. I don't know that's true or not, but I have to wonder that we're running this interesting experiment with increasing CO2, and obviously also methane and nitrous oxide are even greater greenhouse gases, and those are sort of increasing a bit too. So I wonder, I ask myself, do we just pretend to go on as we are, imagining that we're in this natural cycle? And yeah, some plants benefit from high CO2, some plants don't.
Well, if you listen to my talk, obviously I think that global warming is a crisis. I think it's not actually going to take 80 years from now till the year 2100 before we get in trouble. I think heat stress, it's already a problem in hot parts of the world today. I think that could get significantly worse within the next few decades. Let me say just since I've already said that several times, let me say something about modelers. I am a climate modeler myself. I do simple climate models. I do one-dimensional, globally averaged climate models, and I use them to do things like runaway greenhouses and really big climate changes. But when we do our simple 1D models, which is where the field started out 40 years ago or more, I get about 2.5 degrees for doubled CO2 change with the water vapor feedback put in. Now, the IPCC groups do this same doubled CO2 calculation with elaborate climate physics in there. They get about 3 degrees change. The physics is pretty well understood on this. And then, I showed you a graph showing that the climate models, the 3D models, now can reproduce the observed temperature record. So, I don't think one should ignore the predictions of climate models. They're based on physics. We all get more or less the same answer these days, and if you project things into the future, we get in trouble.
So why do we see these long periods since we started adding CO2 to the atmosphere? I'm going to throw it out. We really started pumping CO2 out in the mid-20s, the end of the post-World War II. We've seen about 70% of the time now, we've seen either cooling temperatures or stable temperatures. And why have we seen here, I showed the chart of the United States network data, we've now had at least 16 years of stable temperatures. Well, that's the data says, that's the United States.
I showed you the data.
Well, I just gathered this 3 days ago from the best thermometer data record we have in the United States.
Your slides are still available here, and we could probably get it up here. We can do some dueling slides here.
Yeah, I'll just comment that again, I referred to a study we did some years ago on, 6,000, 8,000 years ago. There is an induction period. So just because CO2 goes up, you may not expect an immediate response. Earth is a buffering system. It responds when it can respond. So, you pump CO2 in there, and there may be different rate constants for different kinds of processes. So it's not easy to just start drawing one-to-one correlation. I want to make the point that that's something we've observed actually in the geologic record. So
CO2 was driving temperature from the late 70s until the late 90s, but now it's not, because it's being delayed, but it wasn't delayed then, I think is what you're saying. So we selectively pick when CO2 is going to drive temperatures. It didn't drive temperatures at all. In fact, it decreased for 33 years in the mid-20th century. It's stable based on the best temperature thermometer data record we have in the United States.
Okay,
So
let's tell us the difference between the two graphs that you've shown of temperature between your graph and
This is off
Greg's.
of Wikipedia, so it's within the last year. It goes up through the last year. I get all my fresh graphs of temperature change from Wikipedia. What's the time period where you say it's staying constant, Greg? The last 10 years? 16 years? Okay, here's the last 16 years. Does that look constant to anybody in the audience? Let's choose the data sets. The hottest year on record was 2 years ago. It broke the old record by a couple tenths of a degree. Now, there was a time before your book was written, right, where it looked, see this flat part here, look, things had leveled off. There's interannual variability, there's interdecadal variability, but it's mostly due to heat transfer with the deep ocean. But look what happened in the last few years. It went up, skyrocketed. We're back on this projection that has been going on for 40 years that the IPCC will tell you, 99% sure that is caused by anthropogenic CO2.
You want your slide up, Greg?
You could
I
put it.
think the
No,
difference-
I don't need it.
The difference is in the data sets that you two are
Well,
using.
yeah, I'm using the latest, 3 days old, data from NOAA, from the best thermometer-based record in the United States that takes out urban heat island. I took my data from NOAA, not Wikipedia.
Right.
And I mean, maybe that's the
But
difference.
your data is the land-based thermometers versus this is the global temperatures from satellites and SST?
That's the NASA GISS record. There's at least 3 groups worldwide that do these calculations. They all get answers that are pretty similar. So it's from Wikipedia, but they get it from NASA.
I had a comment. I was going to say, your last peak there is in the middle of an El Nino event.
That's 2015-16.
So that's a lot of what causes this interannual, interdecadal variability. When you get an El Nino, that means you reduce the transfer of water between the deep ocean and the surface. The deep ocean is cold, so most of the time where you're bringing this cold deep water to the surface and you're taking warm surface water and putting it in the deep. When the El Nino comes, you reduce that transport and you get these, that's when we break the temperature records.
Yeah, I also use this data, but I don't think your data set is up to date because you're showing the 2015 and 2016 El Nino-driven warming event. Since that time, temperatures have fallen back to the same level as what they were before. They just have. This is not up to date. Your last peak that you show there is that 2015 and 2016 El Nino event. And yes, I'm not going to disagree with your allegation that that period of time was the warmest that we've seen in hundreds of years. It was, I agree with you. But we're in a warming trend. When we get a couple of years of exceptional warming due to El Nino, of course it'll be warmer than it's been for a couple hundred years. We're coming out of the Little Ice Age. But this, I don't believe this, I have very similar data, but I'm showing that that same data source that we've seen, if we go and get the 2018, 2019 data, it's dropped considerably from what you're showing here. So we got to be, when we're showing this data, it's good to get the most recent data like I did with 3 days ago.
This goes through 2018, which is the last full year of data. You can't get plot the 2019 data on that until the end of the year because the temperatures are changing everywhere during the year. So you have to, that's why I picked it off Wikipedia because I wanted the most up-to-date graph.
Okay, let's move on. We've got lots of questions coming in from the audience here. This is the first one that came into us, and I think I know a lot of the reasons of this, but I think it would be good for all of the audience to understand. And the question is, what is the reason for the significant decrease in CO2 over geologic time to where, it used to be 2,600, now we're down to 400 or whatever?
Yeah, so can I take that one? This is the faint young sun problem. So, I work on climate on the billion-year time scale. The sun, as I already said, started out 30% less bright than it is today. The Earth would have been an ice ball if you didn't have 100 to 1,000 times as much CO2 as there is today. And, so we think CO2 goes down as the sun brightens. Why is that? It's because the CO2 concentration on long time scales is mostly controlled by the inorganic carbon cycle, not the organic carbon cycle. You weather silicate rocks on the continents and make carbonates, and then that CO2 is returned to the atmosphere from volcanism. Silicate weathering has a negative temperature dependence, so that when the climate cools, the silicate weathering rate slows, and so CO2 accumulates in the atmosphere. If you didn't have that, the Earth would not have stayed habitable for 4 billion years.
Right, I think it's also, in our early Earth's history, we had significantly more volcanism, which was spewing out the CO2, and we did not have the flora and fauna that we have now that is respirating and digesting the CO2, if you will.
Okay, maybe I thought we would all agree on this, maybe we won't. I attribute, why are the CO2 levels going up right now? We're burning fossil fuels. So we're liberating the fossil fuels that have been incorporated and sequestered in the rocks. We're seeing huge amounts of carbon that's removed through, we've got right underneath us here, what do we have, how many thousands of feet of limestone that just locked up lots of CO2? The organic rich shales, of course, that we're liberating today incorporated huge amounts of carbon, mainly through algal blooms that fell and we accumulated in the Utica and the Marcellus Shale and others. So the Earth has been naturally sequestering CO2 out of the atmosphere.
Yeah, I think it's all of the above.
Yeah, we have another question from the audience, and it's probably for Jim, but it doesn't say, so anyone can answer this question. Any model is non-unique with infinite models able to fit the data. What other control knobs could be tweaked to fit the temperature data?
If I could just add a couple words on the modeling. I mentioned that the IPCC didn't used to be able to reproduce the climate record. A lot of that was in the air-sea energy exchange. So these days, these are not just atmospheric models. They're coupled ocean-atmosphere biosphere models. And the meteorologists worked hard for 20 years trying to get the energy fluxes through the turbulent boundary layer to work out, because you have to couple that atmosphere to the ocean. They finally solved that problem. And it wasn't just, then that technology spreads to other groups, like genes spread through biology. But they're doing that now, and they're able to reproduce the model or the temperatures. So we have more faith in the models.
I'll just have to say, in terms of modeling, I'll agree with Jim for a moment, and the models are absolutely correct. But again, we're using these models to predict what might happen many, many decades in the future. And again, what I do is I look at what's actually happening today. We're seeing all these predictions of catastrophic events, but yet we see things like, we're being told that, for example, fires are increasing. But if we look at just fires alone, we see that fires have been in long-term decline globally, North America. Even in California, the number of fires, according to CAL FIRE, have declined substantially in the last 30 years. Area burns increased. That's a forest management issue. So we're being told these catastrophic events are occurring and that they're going to get worse based on climate models, where I like to look at the real-world events of what's happening today and say, no, they're not. The Earth is thriving and prospering, and NASA says that up to 50% of the Earth is greening. Vegetation's increasing. According to NASA, less than 4% of the Earth is desertification. Less than 4%. That's a really good trade-off. That's a really good trade-off. And we're seeing that with retreat of the Sahara Desert, the Sahel, the Southern Sahara, turning into a lush grassland. But again, it goes against the models. The models will say, oh no, the Sahara is going to expand. Let's look at what's actually happening today, and we need to separate speculation of what might happen 30, 50, or 80 years in the future from what's actually happening today.
Okay. Another question from the audience. Could one or more of the panelists, and I do want to say we need to keep these brief. We've got 13 minutes left before we have to break, because we do have a luncheon in this room. Could one of the panelists comment on the relationship of the Milankovitch cycles and the data that we see in temperature and CO2?
Yeah. So Milankovitch cycles, these are these astronomical variations in the Earth orbit. The eccentricity changes on the 100,000 and 400,000 years cycle. There's the obliquity changes on the 41,000 year period, and then they have these 19,000 and 23,000 year precessional cycles. We know beyond the shadow of a doubt that the Pleistocene ice ages have been forced by this astronomical forcing. And this was shown actually by mathematicians before Milankovitch, but Milankovitch made the key connections between the astronomical cycles and the physics of how that affects the climate system. So you get this, you look at oxygen isotopes in deep sea cores, you see these complicated patterns, and you do Fourier analysis on that, and the astronomical cycles, the ones that we know about mathematically, all come out of the data. So it's one of the best agreements between theory and data in all of geology.
I have a question from the audience for you, Greg, as you're now one of the expert reviewers of the IPCC. In your opinion, what type of work should the IPCC be doing to address your concerns and those of others who do not think the science is settled?
Well, The IPCC's there's a lot of really, really good science. I don't mean to denigrate the IPCC. There's really, really good science going on there. What I do disagree with is when nobody reads, each report comes out with a separate section on the cryosphere, the biosphere. I don't disagree with the base science that goes into that. I disagree with what's called the summary for policymakers, where they make these big conclusions. And we see that in National Climate Assessment as well last year, where they reached really a lot of what they're coming up with are politically driven, not scientifically driven conclusions. So I have my problem with that, with the IPC, the National Climate Assessment, recent UN government proclamations of a looming mass extinction. These are politically driven. The science behind, like the mass extinction, there was a lot of really good science that they listed hundreds of papers, but it was their summary of mass extinction that I strongly, strongly disagreed with, and with the manipulation of data we saw. And it wasn't the scientists that manipulated the presentation, but rather the policy makers, the politicians that wrote the summary for policymakers. That's where I draw a really big distinction.
So the IPCC scientists who write the bulk of the report do not write the summary?
That's right.
Huh.
They're involved in that. We get to review and put comments, or for example, whenever Michael Mann did his hockey stick, he was the lead reviewer in charge of that section. This was a huge, huge change in climatology and everything. They should not have put him in charge. He was the top peer reviewer of his own work. That's an example, and that's just one example. And that should not have been allowed.
Okay, let Jim add to it.
I've never been a part of the IPCC, but I know many colleagues, including Mike Mann, who have been part of it. There's a science traceability matrix. There's 2,000 or 3,000 scientists involved in the IPCC worldwide. They write the last report was actually 300-page volumes of report, and then they condense that down to a technical summary, which is shorter, and then they condense that down to a summary for policymakers, which is shorter yet. And you can trace the science in the summary for policymakers through the technical summary and through the reports themselves. It is not a politically driven process. The scientists are doing their best to evaluate the data. And I personally am grateful that my colleagues are willing to spend the man years of effort that it takes to do all that.
I think everyone agrees that CO2 is causing some warming. And as some of Greg's graphs show, much of the warming is natural. We're coming out of an ice age, and we continue to be so. So is there any way to distinguish the natural warming from the warming caused by CO2, or to quantify that in some way?
That was the key figure that I showed you from the 2013 IPCC report. If you put in the forcing from CO2, you match the temperature record. If you don't put in the forcing, you don't match. You have to trust the models there, and because that's the only way to show that the CO2 is forcing the warming.
Yeah, we have a luncheon coming in here. Do you want to say one final point here?
I do. Something's been avoided in this whole conversation is, what if we did reduce all of our CO2 emissions? What would that do? How much temperature rise would be averted using the model for the assessment of greenhouse gas-induced climate change developed by the EPA? If we reduced 100% of the United States CO2, it would avert 1/10 of a degree centigrade, and that's by the year 2100. And by the year 2050, it's 4/100 of a degree centigrade. That's what we're talking about, is we're going to reduce, by 2050, we're going to reduce temperature by 4/100 of a degree centigrade by 2050. How many jobs has that lost? I'll answer, 0. And that's what we're talking about. We're going to economically cripple our country, put people out of work. all the while, and God bless India, they want to lift their people out of poverty, and they're building coal-fired. And China, we're going to be overwhelmed with increases. So that's an important consideration. How much temperature rise would be averted by the United States from us doing that? And that's really not been part of the conversation.
I think Jim wants to add something here before we.
I'd hate to end
finish
on
off
that
here.
misleading note. That's if the U.S. reduces emissions and the rest of the world doesn't. It has to be an international effort. It's a global problem, so you have to have China and India and everybody else signed on to it.
We'd like to thank the panel.
I was going to say the same thing. We're all in this together, and we recognize this. Without that agreement, we're nowhere. So.
Right, this has been a very successful. Thank you very much.